factorization. Done. Alright, you can draw a line and then you can write a heading. Inequalities. Alright, this will be what the sums look like. So you did inequalities in grade 10. All you had was a straight line. There was only one x and then a number, and then you got to a number like x is greater than 4, and if it wasn't included, you didn't color in the circle and you made the arrow go to the other side, and if it was included, you colored in the arrow after dot, and then the arrow was going wherever it was going. Do you remember that? Yes. Not Kumo, you forgot it. Okay, but don't worry. It's not that big of a deal. All I want you to see is that in grade 10 it was linear, 1x. In grade 11 it's quadratic. So that means we're going to factorize. Now, I can assure you that you are not going to get difficult factorizations here. You're not going to have to use the formula to factorize. It's going to be simple factorization. Can you see the answer if you had to factorize that thing? Don't tell me the answer, but can you see it? I hope so. Okay. But now I want to explain to you what the question is asking so that you can understand your answer, because this is a bit tricky to understand. When they ask you, when they give you that sum, I want to tell you that that is an equation. Even though the sign is greater than, it's still an equation. Right. So they, where is my, so they are asking you, do you know what this thing is called? This whole thing? Trinomial, you are right. I don't know, I'm not asking the question correctly. I don't know how to ask you differently so you can give me the right answer. So I will just tell you what I'm actually meaning. This whole thing is normally given as equal to y. Do you agree with me? If we've got a graph, then it would be y equal to whatever. So when we have a Cartesian plane, with x and y values, do you understand what it means when y, or when x is the independent axis? You know what that means? It means that's going to be the one that you put in, okay? And y is the dependent axis. That means it depends on what x you put in, what y you're going to get. Okay? So, for example, if we're baking pancakes, and I ask you, how many eggs will you need to make 100 pancakes. No? I'm asking you about the input, the eggs that you put in, but with the answer of the number of pancakes. Does that make sense to you? So I have a recipe. There's something happening there. If I take a different recipe, I might still put eggs in there, but I'll get something totally different. It won't be pancakes. It depends on what the recipe tells you to do. Okay. So I want you to imagine that X is your eggs. Okay. How many eggs we're going to put in? That square, that minus 3, and that minus 18, that's the recipe. That's things happening to X to result in a specific outcome. Might be pancakes, might be, I don't know what, pizza, I don't know. Okay. So that's the input, it delivers the Y from the output. So when I look at this question, it's actually asking, where is Y greater than 0? Okay? Because that is X. When X is alone, that's X. Okay? It's an independent axis. There X is negative, there X is positive. It's independent. But the result, where Y is, depends on what my recipe is and what my X is. So when I ask you the question, where will Y be positive? I need you to understand that Y is positive at the top and Y is negative at the bottom. So when I reread this question again, they're asking me, where is this graph? Which is Y. It's the result. It's not X, it's the result. Where is it at the top of the x-axis? Because at the top of the x-axis, Y is positive. Does that make sense to you? All of you? Okay. Now, it's always going to be a quadratic function. Now, look at what happens with a quadratic function. Doesn't matter where this thing is positioned. It's positive on the left side. Then it takes a break, it's negative. And then it's positive again. Do you see that? No? Positive, negative, positive. Even if it was a negative graph, then it would be negative, positive, negative. But it's a pattern happening. Okay. So that makes it easier for us. Now, if I give you this sketch and I ask you this question, can you see where this function will be greater than 0, where it will be positive? So I'm not asking where X is positive. I'm asking you where the function is Y. Where is it positive? Can you see on the left? Basically from negative infinity. Because this graph is going up and away. So from negative infinity up to that point, it's positive. From that point to that point, it's negative. No? Even though the X is positive, it's resulting in a negative answer. And after that point, it's positive again. Do you agree with me? Okay. Can I find the value of that point? Who knows what that thing is called where the graph cuts the x-axis? X-intercept. So can't you find the intercept? You can, eh? It's the roots. You remember the roots? What are the roots? The x-intercepts. That's when you let your equation be equal to 0 and you factorize it and you get the points where y would be 0. Those are your x-intercepts. But do you see those values aren't the answer to my question. They're just the borders. That's how I know from here to that border it's positive. Between the borders it's negative. Greater than that border is positive. So we will definitely need to find and factorize that to find the x-intercepts. But that's not the answer. So I'm going to say bracket, bracket, factors of 18 that will give me 3 when I subtract them. What is it? 6 and 3. Which one will be negative? The 6, and then the 3 will be positive. So I've got two answers. X is 6 and x is negative 3. So this means this value is negative 3 and this one is 6. So can you answer my question now? Where is this function greater than 0? It's going to be from negative infinity to negative 3. And then from 6 to positive infinity. That's easy enough, no? Now we must just write it correctly. Now there are two notations that we can use. We can either say negative infinity not included, because you never include negative infinity because it's not a specific number, up to negative 3. So the question asks, where is it greater than 0? So should I include negative 3? No. Because at negative 3 it's equal to 0. If that thing was asked greater than or equal to, then you would include negative 3 with a block bracket. And then 6 to infinity. Infinity not included. Must 6 be included or excluded? Why included? Not included. At 6 it's 0. The question asks bigger than 0. Not bigger than or equal to 0. Just bigger than 0. Now look here. I'm going to explain it to you again what I'm saying. If you take any value smaller than negative 3 and you put it in the place of x, you use it as an input, it would result in a positive answer. Okay? If you take any value greater than 6 and you substitute it into x, it would result in a positive answer. And I'm asking not the value of x, I'm asking for this whole recipe of x. And therefore I'm asking for y. If I put in negative 2, it will result in a negative y. Negative 1, it will be a negative y. Positive 1, it will be a negative y. Positive 2, it will be a negative y. Positive 3, it will be a negative y. Positive 4 and positive 5, they'll all be a negative y. Because even if 5 is positive, when you square 5, you get 25. But you have to subtract 3 times 5 again and subtract 18. So that's why it becomes negative. But even if I substitute in negative a million, billion, gazillion and I square it, it's going to be much bigger than 3 times negative a billion, million, gazillion. And then the two negatives will become positive. And then I subtract 18. So even if it's the biggest negative number you can think of, it will result in a positive answer for y. Okay. The second way that you can write this answer is you can write x must be smaller than negative 3 and x must be greater than 6. Now, if you write x must be smaller than negative 3 and greater than 6, you write it like that, then you will get 0. I want you to think about this, writing this mathematically. Think about it mathematically. What on earth are you writing there? Is your answer between negative 3 and 6? X must be smaller than negative 3. So it must be on that side of negative 3. And it must be on that side of 6. But now it's in between negative 3 and 6. Do you see the problem? It doesn't even make sense mathematically. So if your answers are on the outside, so you've got two sets of answers separate from each other, then you write your answers separate from each other. Is that clear? Okay. Now, when we're going to do this for a test, you're going to get your mark there for your 2 0 points, and you'll get a mark for each one of those, and then you get a mark for the correct, writing it in the correct way. So separating them. But if you write them together, you get 0. You will only get 1 mark for the 2 0 points for those two answers. Okay. Now, another example that I want to show you. Now, did you notice we were working with a positive quadratic function here? Now, I want to show you what happens if we're working with a negative quadratic function. Nice nap, Khali. I don't know why you are here. I'm serious. You and you. Those were the two I saw today. Sleeping. We are all working hard. Okay, so when this was a positive graph, it's easy because it's positive, then negative, then positive. Okay? But when it's a negative graph, it swaps around. So it can confuse things for us. So we are going to make it easy for ourselves. We are going to manipulate it. Because you remember, before you factorize in any case, you get the coefficient of x squared to be positive. Okay? We always do that before we factorize. So if can you see this is not standard form and it's not, the x squared is not positive. It should look like this, firstly. And then I don't want that thing to be negative. So I can multiply with -1 or divide with -1 for this to become positive. And then this one's going to become negative. And now, do you hear what I'm doing? I'm dividing or multiplying with a negative. Do you remember what should happen now? That sign must turn around. And there it is. So do you see, I've made this thing positive. So it's still going to be positive, negative, positive. It will always be negative between those two, but now you might feel like you don't trust this thing. Because the question or the function is negative, and now I'm asking about a positive one. Now I want to show you. Okay. When you look at this function, do you agree with me it's a negative one? No? Its 0 points will be 0.5. Believe me, I did the factorization. Okay, but we're going to do it now as well. So this graph will look like this one. And they are asking where this graph is greater than or equal to 0. So do you see it's between 0.5? That's where it's positive. Now this function is positive. It has the same 0 points, 0.5. It looks like this. And because I manipulated it correctly by swapping that sign around when I divide it with a negative, it's asking me for the space where this graph is negative. And that's exactly the same answers. Do you see? Okay. So you don't have to worry about it. When you've made it positive, like here, then you're going to start working with it. You ignore that negative thing there. We don't work with it when it's negative. So you get it positive into standard form. Once it's positive and in standard form, then we're answering the question they're asking. From there on, we answer. Okay? So when I factorize this, I will help you. You take out the x in common. It will be 2x minus 1. Close the bracket, smaller than or equal to 0. I get my two answers. The one is 0 and the other one is a half, because the one goes over and then I divide with 2. So now you know where I got 0.5. And now the question is asking smaller than or equal to 0. So because I'm always going to work with a positive graph, the smaller than, the negative, will always be in between the two intercepts. That's the one notation that you can use, or you can say x greater than or equal to 0, smaller than or equal to a half. I'm just saying, if you write it like this, x smaller than or equal to a half, greater than or equal to 0, you will get 0 for that answer, because that's like writing your name backwards. Do you agree with me? Okay, so it's always the smaller one first. Do you understand why I included the intercepts here? Because they're asking for smaller than or equal to. When they only ask smaller than or only bigger than, you don't include them. When it's smaller than or equal or greater than or equal, then you include. Is it intercept with a S or a C? Like that? You sit. Sit. I want to show you some done writing. Okay? I want to show you, for example, so you can believe me. The first one in the textbook, do you see they're asking for smaller than or equal to? You get your 0 points. It's in between. In between. That's what we just wrote down. If it's asking smaller than, it's in between. You must decide for yourself the including or not including. We are way past that, ne? Alright, yeah? Greater than. Outside. Outside. So you get your 0 points, you write them separately. Smaller than -5 and x greater than 5. Yeah, they're asking smaller. It's in between the 0 points. Greater outside of the 0 points. Greater outside of the 0 points. Smaller in between the 0 points. With each and every one of them. Smaller in between. Greater outside. Okay, now I want to ask you one question. Look at Jay. Look at Jay. It says 1 minus 2x, x plus 3, and then they're saying smaller than, but the answer is on the outside. Can you tell me why? I will tell you why. That x is not at the right place. Do you agree? Our bracket must be x plus minus constant. X plus minus constant. So what you're going to do there is you need to take out a negative. And then you multiply each side with a negative. And what's going to happen then? And then it's greater than. And then it's right. Do you understand? So what you're going to do for me tomorrow on page 51. Are you ready? B, C, F, H, I, J, K, and L. It seems like a lot. I promise you, it's quick. You factorize, then you say, are they in between? Are they outside? You don't draw sketches, you don't do nothing. Get it in standard form, factorize, smaller than, in between, greater than, they're on the outside. It will take you no longer than 20 minutes, I promise you, okay? I'm going to check your homework tomorrow, Bungani.
Yes, Mama.
regtig asseblief môre, jy weet. Okay. So, dit kom nie van die skool af nie, dis nie vir ons enige iets nie. Niemand dwing jou om enigiets te doen nie, maar dit gaan oor die vaccinations. Okay. So al wat jy op hierdie brief gaan invul, is die departement van gesondheid wil kom gaan na die skool toe kom en jou verniet hierso vaccinatie. As jou male daarvoor toestemming gee. Maar jy hoef dit met niemand te bespreek nie. En jy hoef niemand te beïnvloed of jy gevaccineerd wil word of nie. En as jy dink ek is stupid, kom ek sê sommer vir jou,